Hey, what's going on, guys? There's a lot to absorb here. I don't want to call it a brutal and unforgiving slog, because that would be unfair, but it definitely is a brutal slog, and it is sort of unforgiving. So here's the deal. There's some complexity here. If you've got an application, let's say a couple of scripts that are supposed to do things, at some point you're going to want to test if something is true and then make other decisions based on that test. So I'm going to introduce the first sort of control flow statement, the if, in this one because it just meshes really well with testing, which is going to be the brunt of this video. I recommend you simply watch this video, work alongside it. Even if it seems simple while you're listening, really do the examples on the side and it'll just sort of become second nature. It's one thing to listen to this and say, oh yeah, it sort of makes sense. But really the only way to get this into your usable knowledge, practical knowledge, is to go ahead and even if it's boring, go along with this and type along. Try these things in your own shell, create your own source files based on, I tell you how to do that in the previous tutorials in this playlist, and follow along. Okay, I really can't stress that enough. First, we'll just start with an if. Okay, you've got some kind of decision to make. Down here, I've just stubbed out some sort of decision I want to make. If the name that we have and the name variable is Dave, we're going to give a greeting. If it's Steve, we'll do something else. And if it's neither one of those, we're just going to shake our head slowly because that's how we roll. If you're in an IDE, an integrated development environment, that is, if you're in some sort of advanced editor, like I'm in Sublime Text right now, but if you're in Vim or if you're in Emacs or any of the other great editors out there, you'll probably have some sort of auto-completion for if in Bash, right? So I'm just going to hit enter, and this brings us to our first problem. This is what if looks like on most modern Linux systems. So you've got an if, then you've got a test for a condition. Just start thinking of these brackets as test. Just say test when you see them. If this test for some condition evaluates to true, then, semicolon, then we do some stuff based on that. And then this is just if backwards, right? So this ends the if block. Don't forget these. This brings us to our first little niggle, and that is portability. Generally, you'll want to write things so that they're as portable as they need to be. It really sucks, though, if, for example, you need to deal with a Solaris system or a BSD system that does not support, we're basically in a shell. Let's say the root shell for that system is not something like Bash. It's C shell or like the original Bourne shell or something that doesn't support this kind of syntax. For that reason, we're actually going to use, this is called the new test, and only a single square bracket is called the old test, and that's just a little bit more portable. So I'm going to show examples with using the old test, so the single bracket syntax. If you're writing a script that's just going to run on Linux, that's going to run in a modern shell like Bash, then you can use the double square bracket syntax. That's called new test, the new test syntax. It's going to be a little bit simpler, which I'll get to later. So the new one is better but less portable. The old one is more portable but a little bit more annoying. So this is what an if statement looks like, an if sort of block here. From if to phi, this is all the if statement. This is the test. You're testing some kind of condition. If that's true, then you do this. So old test, name equal to Dave. In a lot of other programming languages, this is assignment, and the comparison operator is 2 equals. That's what you get with the new test syntax, but we're not going to worry about that right now. So if the name is equal to Dave, we're going to have to set a name somewhere, huh? So let's just use the first argument that we get. Remember from the arguments video that the 1 variable is the first argument that's passed in. The 0 is the name of the script, the number is the number of arguments that have been passed in, that's the pound or hash operator symbol. But we want 1, the first argument passed in. So if the name is equal to Dave, then we'll echo hi Dave. Now let's just go ahead and try this in the shell real quick. First we'll go to bash, we're not cheating with Z shell. Code bash, and then we'll say search mod. We're going to add the execute bit so we can execute this as a script to if. And then we're just going to run if, and we're going to say Dave, and it works as expected. Hallelujah. If we don't do this, you can see the condition fails and nothing happens. The script simply ends. This is never executed. If the name that we pass in, which is this argument here, name of the script, argument 1, so that's argument 1 in this variable. If this variable is Dave, then we echo hi Dave. Also remember that lowercase Dave is not the same as uppercase Dave, so this would do nothing. Okay, however, we need to check for some other things. So for that, we've got the elif statement, which is optional. You can have as many of those as you want. And then an else statement, which gives us a default case. If nothing else matches, if nothing else has been true, you can do some last thing. So I'm going to send this off to another desktop. There we go. So if our name is Steve, we want to tip our hat. So what we need is the elif statement. So again, sorry, it gives us the new test because again, this is probably how you're writing stuff for just your Linux system. It doesn't have to interoperate or be portable to another operating system. So if the name is, let's say, it was lowercase, right? But we'll change it to uppercase. If the name is Steve, then we'll say, you know what we'll do? We'll just make it a little bit more variable based here. Greeting hat tip is tip of the hat, and then the head shake. Okay, got our variable set, the name, the greeting. We'll just echo out and we'll say echo the hat tip. And we've got the otherwise, so then you can just say else, and then whatever block you need there, you'll say echo head shake. Now, if I didn't make any silly mistakes, this should give us the behavior we want. So we'll test Dave, we'll test Steve, and we'll test something else, or nothing at all. So let's say Dave, hi there. We'll say Steve, and we'll say nothing, perfect, and we'll say booger, because we are 12 years old. So again, this is exactly the expected behavior. If it's nothing, so if it isn't one of these, that is if it's nothing or if it's something that isn't Dave or Steve, we get the behavior we expect, which is a slow head shake. If it's Steve, we get a tip of the hat, and if it's Dave, we get our greeting. So if you're generally stubbing out code, obviously this is extremely simple and doesn't really require comments, but a nice way of writing code is to simply stub out what you need with comments, and these are sort of your pseudocode, and then as you write the code, you just indent under the comment that describes it, and then do your thing. And then voila, you've got commented code, more or less. So we're going to save that, and now we're going to get to the brutal slog. Are you ready? Testing is what we're really here for. Let's say we've got some number of required arguments. Let's say we need at least 2 arguments, and we want to test for that. This goes back to the arguments variable. Number of arguments here. That's this pound or hash symbol. There are a whole bunch of different tests. Things like this. Testing this against a number here, and then doing something based on that. Just as a realistic example, I'm going to comment this again. So in this case, this is less than. If you're comparing integers, numbers, if the number of variables that were passed to the script when it was launched is less than this variable, which is currently set to 2, so if the number of arguments is less than 2, then we echo the usage string. Just to give you an idea of realistic usage. So we've got some helpers that I've mentioned them before in basic shell videos, but just so you remember this is the OR operator, which basically means it's going to try this first thing on the left side of the OR, and then if that returns a success, then that's good enough because that's true. This is asking, is one of these things true? And the way it finds out is saying, is the first thing true? And if it is, it says, oh yeah, this is true, and that's enough for us. And if the first thing is false, like here, like this is a non-existent file. I'm asking it to list a non-existent file, which is going to be an error, so it's going to come back as with an error. So this OR will say, well, maybe the statement 1 is false, but maybe statement 2 is true. So this thing will run. I'm just going to run these quickly so you see it in the shell. Let me just open up a new shell here. Just so I'm not cheating, go to bash. I'm just going to paste this in. So what's going to happen here, don't just look, try to figure it out first. It'll help you learn. So we're going to echo hi. This is going to work. It's going to return 0. It's going to be a success. And the OR will already know that it's true, so it won't need to see if the second thing is true, because one of them is true. And that's what OR asks. OR says, is this or that true? Is one of them true? So we've simply got a hi. Now, if we replace this with the second one here, where we list a non-existent file, the OR will trigger the second thing to run, because the first thing didn't work. So you can see this is the command. This is actually standard error being piped to our shell, so we can just ignore this. This is saying, it didn't work. And because it didn't work, this evaluates to false, and the OR says, well, the first thing's false, but since I only need one of them to be true, let's try the second one to see. And that's just a simple echo statement, which is then executed. A little bit complicated, but if you just try a couple things that use this operator, and it'll make sense to you. The second one is AND. This is really, if you need two things to be true inside of a test, you would use the ampersand, or the AND operator. And that's when you need both things to be true for this to test out to be true. So both things happen. If one of them is false, we'll just say, instead of making this an echo, we'll just have it be, how about list non-existent. So that only gives us the error. The thing is, because this fails, it already knows that both can't be true. So because the first thing failed, it's not even going to try the second one, because you can't have both be true anymore, because you already know that the first one is not true. Failed. Okay. Now let's talk about comparing things in tests. So we've got these if statements that are testing for things. We're using the old style tests. Again, the new ones simply have 2 square brackets instead of 1. And the syntax is, you can use the same syntax for numbers and strings, which makes things a lot simpler. We're setting 2 strings here. I'm going to comment this stuff out so it doesn't sort of go into our shell when we run this file. We've got 2 strings, and we're simply testing. So we're saying if the first string is equal to the second string, then you can print out that, whatever that is equal to the second one. If they are not equal, then we're saying it's not equal. Again, the thing you need to remember is simply these symbols here. The equals compares string, a single equals, using in the old test. Exclamation mark equals is the is not equal operator. You can think of this as simply a, like an equal sign with a line through it, like in math, not equal. Well, this is the line. So is not equal to string 2. That's how you check. So we're testing for not null values, -n or 0 length with the z operator. So this is clearly not null. So we're just making sure that it's not null. You'll use this as a guard a lot for user input if it could be empty. Like if it's an optional argument, for example, you'll just check. Before we use this thing, let's make sure it's not null, and then we'll use it. So it's sort of a guard. So this has something in it, so this will turn out to be true. It's not null, so we can go ahead and echo something. The z tests for 0 or null value. So you've got an empty string here, just 2 double quotes, that is null. So if the nully variable is null, which it is, we're going to echo nully or 0. Let's just check that in the shell really quick. So this is the output we care about. This is for integers, for numbers. So a is not equal to b. We get that output. We get this is not nully and nully 0. So both of those things end up being true. So that's not null, and this is null for a string. Okay, now integers. We're again setting up some integers. integer 1 and integer 2, int1 and int2, 1 and 7 are their values, and this is how you do in the old test style equality testing. This is equal and not equal, dash EQ and dash NE. This is greater than GT, less than or equal, less than LT, and less than or equal to. Oh, and sorry, I doubled up on that one. Greater than or equal to. So GT, LT, GE, LE. A little bit annoying to have to treat integers differently. In the new test syntax, so double square brackets here, you would simply be able to use the same operators as for strings. So you'd be able to do, and this is what most programming languages do. So you have equals, not equals, and then greater than or less than signs. That would be these. And obviously equal to. So greater than or equal to, less than or equal to. But we're doing it old school in case you have to troubleshoot one of these things one day, which you will, and then you will be thanking me that we're doing it the hard way. Okay, so greater than, less than, equal to, etc. Same stuff. You can use string comparison operators if you use double quotes in the old testing style. So, sorry, double quotes, double parens. So you can compare integers using this sort of new style syntax if you simply put double quotes instead of single brackets around them. Again, you can see that this is kind of, it's not the end of the world, but it's complicated, and it's complicated enough to trip people up if they're not doing it all the time. Like, it's been a while since I wrote Bash in production. It would be like, the last time I wrote Bash scripts of any complexity would be like a year and a half ago, simply because I was working on like some embedded stuff that didn't have Python or a real interpreter on it. I didn't want to do it in C because stuff would change often, and I didn't want to have to deal with cross-compiling. So it's a Linux system on there. We can just use Bash. But if you ask me to write anything complex now, I would make all kinds of mistakes, and I have to test it. I have to run it. So don't feel stupid when stuff doesn't work. This syntax isn't exactly intuitive. Simply follow the examples, type it out, and before you know it, you'll sort of have a handle on it. But again, it doesn't come from just reading this or looking at this tutorial. You have to type this stuff out. You have to do some stupid examples. Try to think of some stuff that you'd like to do on your computer, like run some backups, maybe make a little game for yourself where you give it some input and it gives you some output based on that, like a guessing game for a number, that sort of thing. Just practice. Find some way to practice. Again, here is the syntax which you can use for strings natively. This is actually just a single, in the old style, this is just a single equals. In the new style testing, it's double equals, can be used too. And you can use these in the double parens for integers as well. Does that make sense? Strings and integers are treated a little bit differently when you're comparing them, but you're going to use it all the time. You've got and, you've got or, which decides if something is true based on a more compound set of statements. If they're all true, then the and is true. If one of them is true, the or is true. And you've got, really, this is where you'll be seeing it the most. You're just writing a program. You're going to be saying if something is true, then do that. Oh, if this other thing is true, then do something else. And you can do this ad infinitum, right? You can have as many elif clauses as you want, but you can only have one else. So this is your default case. It is optional, so you don't need an else. If you just want to check for some amount of cases, and if none of them match, then you don't care, you can do that too. So again, the if is the only required part. All this stuff is optional, including the else. All right, that said, you probably have a pretty good grip of basic if usage now. Thanks again for watching. I know this is kind of dry material, but we got to do it. It's just stuff you have to know. So at this point, you probably have enough tools to start writing scripts of some complexity. There's a couple more things we're going to cover, like loops and other looping, while, for, and functions. But we're most of the way through Bash. It's really not that complicated. And again, for things that are complex, you're probably not going to be using it. So this really is for like quick one-off, repeatable things that you just need right now. Remember to thumbs up if this is helpful. It helps me decide what kind of content to make next. Also subscribe, check out the website, tutoriallinux.com. And I'm on Facebook and Twitter as well, /Tutorial Linux in both cases. Thanks again for watching. I'll see you guys there.